Hi! So on my SPI to Ethernet networking card, I'm using the WIZnet W7500 chip to give me a bridge from SPI to Ethernet. And this chip embeds a ARM Cortex-M0 processor and WIZnet's hardwired TCP/IP core. In order to use this chip for my networking card, I need to write some software which is executing on this chip. So I thought maybe it's a good idea to start a small series of videos in which I will show you how to get started writing software for the WIZnet W7500 chip. So in this series of videos, you will learn a little bit about how to program an ARM Cortex-M0 processor, how to use a vendor's SDK for a specific chip, and also a little bit about embedded interfaces in general. So I want to present you all the embedded interfaces I have to use for my networking card, and you will also learn how to write good makefiles, hopefully. But first, maybe let's take a brief look at this W7500 chip and let's take a look what's in it. So we have one ARM Cortex-M0 processor core, which you can clock up to 48 MHz. We have WIZnet's hardwired TCP/IP core in it, which gives us 8 sockets, up to 32 kilobytes of SRAM, and a media-independent interface to which we can connect our Ethernet PHYs. WIZnet is also offering another version of this chip with a built-in Ethernet PHY, but this one is only limited to twisted pair Ethernet. Okay, what else do we have? We have an 8-channel 12-bit ADC. We have a DMA controller with 6 channels and support for UARTs and SPI. Maybe I will take a look at the DMA controller because I think it's quite interesting, but I can't promise this to you right now. Then we have 53 general purpose I/O pins. In order to debug the chip, we use serial wire debug, which is also used on STM's microcontrollers. Then we have various timers and PWMs, so we have one watchdog timer, 4 normal timers, and 8 PWM timers. For communications interfaces, we have 3 UARTs, 2 SPI interfaces, and here I see 2 I2C interfaces, but I haven't seen anything about I2C in the reference manual. So we also seem to have some crypto functions built into this chip, and we also have a random number generator which will generate 32-bit random numbers for us, which maybe also can be quite handy sometimes. Okay, so how can we start writing software for this chip? So I went to WIZnet's GitHub repositories and I found the W7500 repository. Okay, here we have a warning message that this repository is no longer supported, but for today we will ignore it and I will update to this newer version in a later video. Because I don't want to use WIZnet's default structure, but I want to create my own project structure and I will only include the files from WIZnet which I really need. Okay, and another reason why I choose to use the older repository is because here we have examples with makefiles. So every example project has its own makefile. This makes it a little bit easier for me to get started. So I would say the first thing I will do is I will take this link here and I will clone this repository. Okay, in order to build code for our ARM Cortex-M0 core, we need the ARM non-ERBGCC compiler, and this compiler is available in most package managers for Linux or for most Linux distributions, and we also need make to run the makefiles which were provided with this example. Okay, so maybe let's take a look at the W7500 repository here. So here we have some library examples. Okay, here we have IO library, libraries, projects, and utils. I think projects sounds promising to me. Yes, maybe peripheral examples, and here we can see the various peripherals. And I will start with a GPIO example because I think that's one of the simplest I can get. And here we have a blink LED. I think this looks fine. So let's jump into this folder here. And in here we have our main.c file, and we have the option to build this with 3 different compilers, I think. So I have the GNU C compiler available, so let's jump directly into GCC. And here we can see we have a makefile available. So let's run make and try to build this project. Okay, I'm getting an error. Make C Windows System 32 command.exe is not found. Okay, so this makefile seems to be written for Windows, and if we go down to the bottom we can see this line here. The shell it should use is the Windows command line. I will comment this out because I'm running Linux here, not Windows. And now I will run make again. And you can see it's executing some commands here. And I'm also getting some warnings. And here, this cool thing is the commands which are executed are printed out, so I can see all the options which are passed to the GNU C compiler. But this here, so it basically compiles the ELF file in one single compiler command. And in general, this is something which is not so common for embedded programming. Normally you first compile all the C sources into object files, and then in the second step you're linking your project together. But we will talk about the various flags we can see here later. And another little bit odd thing is the output it gives us here is this .o file. And normally a .o file is an object file, but if we take a look at this .o file, we see in reality this is an ELF 32-bit ELF file. So the ELF file containing all the code we can load and run on the microcontroller. And normally the extension for this would be .elf and not .o. But hey, never mind, we will do it a little bit different when creating our own project structure. So yeah, with this knowledge I think we can start creating our own project structure. So I will create a new folder in my programming folder, and I will call it WIZnet examples. And then in here, maybe I will create some more folders. So I want to separate a little bit the thing or the sources which are coming from WIZnet and the sources I have created by myself. So the first thing I will do is I will create a WIZnet folder. And in this WIZnet folder, I will create a source folder and an include folder. And yeah, let's create this here. And then in the include folder, I also want to include a CMSIS folder in which I will put in some header files which are useful for the Cortex-M0 processor. Okay, and the next folder I will create is a linker folder in which we can copy in our linker script. So the linker script basically is telling the linker where it can put the code. We will take a look at this just in a minute. Okay, now let's take a look at this compiler command here. So the first flag we are passing to the GNU compiler is the -g flag. This flag stands for please build me an ELF file with debug symbols so I am able to debug my C source code on the microcontroller. -03 is the optimization level, and 03 is the highest optimization you can get. So with the GNU compiler you have 4 optimization levels. So 0 is the lowest one, 3 is the biggest one, and you can also optimize the code for size. Then you would write -os. Then mthumb tells the compiler to use the thumb instruction set for the processor. And here we are telling the compiler, please compile this code for a Cortex-M0 CPU. Then we are telling it the files it should use for the compilation. So in here we have the startup code. Then we have our main.c file. We have some interrupts here, and we have our library for the GPIOs and a system file. The next section we can see here are the include files which we are using. So we are using the CMSIS files, which offers us defines for the Cortex-M0 processor in this case. Then we also have the include file in which our GPIO source is, And yep, here we have another include. And here we are telling it, please search for libraries in this folder and link these libraries. Here we are setting some defines. And here with the -t option, we are passing in the linker file to it. And this last one here is where to write the output file. So what do I need for my own structure? Well, the first thing I need is I need to copy some includes. So let me grab this path here and copy everything from this folder here into programming, WIZnet examples, WIZnet include CMIS. Then I will copy everything from device WIZnet include. Let's take a look what's in here first. Okay, these two files, I think we can grab them too. And I will put this also in this folder here, or maybe in this folder here. Okay, what else do we need? Source. The other twos I will skip because first I will just write an empty main function, so I don't really need it. But what I need is I have to copy this linker file here. So let's also do this. And I will copy it into WIZnet linker. Okay. And then I need this source file here and this source file down here. So let me copy this here into WIZnet source. And I also told you I will need this system.c file as well. Okay. And I think I will also need this file containing the system interrupts. This here I will also copy. Okay. And then I think I've copied the most important things and I can change into my own project folder. And if we run tree here to see the structure, we see all the files which were copied over. The next thing I will do is I will create a new folder I will call hello. And in here I will create an empty C file, or an almost empty C file. So I will include standard int, and I will create a main function. And in this main function, I will create the unsigned int 32-bit. I will call I will set it to 0, and in an endless loop I will increment I. And here I will return 0. So a very simple main function. Okay, now my last goal is, and then I will end this video, to compile this main.c file into an ELF file. So I will call the ARM non-ERB GNU compiler. Then I will just copy these C flags here. Okay. Then I have to specify which files I want to compile. So I want to compile WIZnet source startup code, WIZnet source system.c, WIZnet source the interrupts. Then I want to compile my 01 hello main.c file. Now I have to specify the include paths I want to use. This is WIZnet include and WIZnet include CMSI. What else do we need? Okay, then we need to pass in our linker script, which can be found under WIZnet linker. Then I will add the option no standard library because I don't want to compile a standard library here into this code. And then last but not least, I have to write my output file, which should be hello.elf. So let me try to run this. Okay, I forgot one header file. Okay, then let's search for this header file. So in temp, we 7000. I will search for a file with the name, with this name here. Okay, we have it in every project folder. Maybe let's open up this file here to check if we need more than just this one header. Now this is looking good, we just need one header. Okay, so let me also copy this over. it.h, and I will copy it into programming, WIZnet examples, WIZnet include. Okay, then I will jump back into my folder and I will run this compiling command one more time. And it worked. And when we take a look at hello.elf, hey, we see we got a statically linked elf file for 32-bit ARM processor. Cool. So I think that's it for today. In my next video, because this command here is a little bit clumsy and long, I will write a proper makefile to automate the build of this application. So I think that's it for today. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy me a coffee on buymeacoffee.com/for Linux. So thanks for watching and goodbye.